Hello everyone, I am Dr. Suman Samanto and I welcome you to the course Simulation of Business System and Applied Approach. And today we will be discussing about simulation with Arena. Today we will show how the various nodes of the Arena can be used to develop various models. So today we have only one point agenda, that is how we use various nodes under different scenario of a banking system. So the thing is that there are, you might have seen when Professor Philip has shown you the Arena GUI, you have seen there are several nodes are available, but today we will show that how these nodes can be used to develop various scenarios. We will use a simple banking system here, and we will develop various cases, and we will show that how those nodes can be used on those various cases. So first of all, we would like to define, we would like to discuss about a banking system in brief, and then we will discuss various cases, and then we will develop the Arena models of those cases. We will take here that a customer when enters into a bank can have only three things to do. Number one is deposit or withdrawal of money. Second is making a bank draft, and third is other things. That includes he may have some discussion with the bank how to open their bank account and any other thing. So we will put all these things to this category other thing. So as you know, so in this banking system we are basically considered three major things that a customer will be doing. Then one more thing is that this is basically what we are trying to do is that we are developing a model, simulation model from a real life situation. We are not developing something which we are going to establish or something like that. We will at the end of each case we will discuss some managerial aspects of the run, so that we can try to find out whether how the system is going. There is a requirement of some extra window, or there is a requirement of removal of a window, something like that. We will start with case 1, where a customer arrives at bank and we are basically counting the arrival rate as same, and then the customer, depending upon their requirements, they go to a window, and there is a separate window for different operations that a customer needs. So when we draw a process flow of this bank system, we will start with the create node. The create node signifies that the customer have arrived at the bank door. Then once it arrives, it decides where he wants to go. So we will require a decision node. As we have said that for this case we have a separate window for separate operations. So, and we already have discussed that we have mainly three operations available in this bank. So we have similarly three kinds of flows will be coming from here. One process, first process, second process, and third process. So this one is deposit and withdrawal window. This is draft making window, demand draft making window, and the third one is other work window. So once, if you have ever went to a bank to make a demand draft, you can see that once the draft is made in the window, it goes to the manager for signature. So for making a demand draft, there has another process left, that is signature in the manager. Once the signature is manager has been signed the draft is developed. However, for the other cases, it will directly go to the, a customer directly leaves the system. Node is developed based upon the past history, and we can in this case we will estimate that there are maybe 60% of the customer will be opting for deposition or withdrawal. There may be 30% of customers who will be opting for draft, making demand draft, and there will be other remaining 10% of the customer who will be developing the other services of the branch. So these processes mainly when we saw a system which is run mainly by the human, then there is some set of rules that if you can go through the simulation modeling in any standard simulation modeling book, you can find that there are several considerations that we take when we estimate the processing time for various processes. So for example, if the process is mainly run by humans, then we'll use normal distribution, human run process. So in this case, all these processes will be considered as normal distribution. All these process times are follows a normal distribution of something, mean and standard deviation. So now we have developed this process flow. We will go to the Arena simulation software and we will try to develop this model in the Arena, and we will run it, and we will try to see the managerial aspects of it, like how this process is actually working, whether we need to include some other window or we need to exclude some other window, this kind of things. As I said in the previously, we will start with create node. Create node basically signifies when this customer arrives at the bank. Then we will have a decision node, that will be signified by this decide. I will come to how we will put the values on this. I will come to that later. Then we will have three processes. One is deposition and withdrawal. Second is making a demand draft, and third one is other processes. That must be deleted first. And then with demand draft, there is another additional process. And finally, once all these things happens, the customer leaves the system. Okay. So as you see in the create node, we can rewrite it as customer arrival. So another important thing is that when we have a human arrival in a system, we normally use exponential distribution. When in a process industry, we go for various processes. Go through various processes, milling, drilling, and other things. Then we normally use this constant this constant arrival. That is because we already have inventory for that. But for human, we normally use this random exponential distribution. So say for example, for this case, for this particular bank, we have 2 arrivals per minute having different. One arrival per 2 minutes having, if you see this, there is a entities per arrival is 1, and every 2 minutes there is a 1 entity per arrival. That is the random mean of the random distribution, random exponential distribution. So that's all about the create node. Then we will have decide node. As we have already said that there has 3 kind of processes, so we need to have 3 decisions. So as you can see, as you can click on this type radio button, then you can see there are several choices: 2-way by chance, 2-way by condition, n-way by chance, and n-way condition. We will come to this condition case later on. Since we have more than 2 chances, so we will use 2-way by chance. So in the first case, we have we said that there will be 60% of the cases where customer will opt for withdrawal and deposit of the money. So first case is 60%. Second is 30%, where people will be opting for making demand draft. And when we use 3 decisions, 3 kind of customers, then we need to define 2 things, 2 percentages, and third percentage will automatically taken by the default case. As you can see here, there has 2 already dots are available. So as you can see, there are very small 2 dots in these. You have to connect these processes with these 2 dots. I will show you how to connect them. So you can see that whenever you bring this plus sign near this dot, you will see this green square. So you have to touch there first, and then you have to close it here. Similarly, a similar thing you have to do for the second, that is 30% case. That is for the people who are making the demand draft. You have to bring this. You have to bring this green circle near the second dot and then touch it, and then you have to touch the third process. And For the third case where the once 60% 30% has been done, the remaining 10% case, that is basically default end case that you have to touch here and then you have to put it here like this. Similarly, this thing has not been joined yet, so I am joining this. So as we said, the first process is basically the withdrawal or deposition of money. So we will name this as withdrawal stag dep. So similar to the cases that have been discussed by Professor Philip, we will use seized delay release in this case also. We will add one resource, that is window. We call it as say for example window 1, and we have one quantity only, so we put it like this. So this is basically withdraw deposition window. Then the second process is basically the draft making, demand draft making. We will call this draft. Revision, we forgot to give this time window here. As I said earlier, we will use normal distribution here. We will use minutes as a time. So say for example, we have given the time taken to avail this service is basically with varies with mean 5 minute and standard deviation 1 minute. So similarly for the process 2 also we will name the process as draft. We will use seized delay release. We will add a resource whose name is say window 2. Similarly here also we will use normal distribution. So for example, this process takes around 3 minutes of time with a standard deviation of 0.5 minute. So similarly third process we will rename it as others. We will use that seized delay release again. We will make the resource name as window 3. Again we will use here normal distribution, minutes. This one takes maybe 10 minutes with a standard deviation of 2 minutes, because in the other case we are basically covering a large number of areas, then people may have lot of queries. To resolve these queries it may take some time. Similarly for the process 4 also, we will make this as a rename this process as signature. We will again use seized delay release process, seized delay release, and we will make the rename the issues name as a manager, since the manager needs to sign this drafts. Again we will use a normal distribution. Say for example here also put it as a minute, and say the manager requires 10 minutes time with a standard deviation of 2 minutes. To sign the document. So we haven't. So as you see, if the customer needs to do only money withdrawal or other things, so they do not need to meet the manager, they directly go to the exit. This disposal is basically I am trying to make it in such a way that it is visible. Minutes, right. Disposal is exit of customer. Now we are in a position to run this simulation model and look into the system, how systems are working. So we will make the setup correct. So replication length we are taking as say for example for a month, so 240 hours, 8 hours per month per day. Okay. Now we are ready to run this system, and let's run it and then check how system is working. I'll make the speed a little bit higher so that we can reach to the result earlier. So that is the end of this run, and we have already got the result. So when you see the result, you can see that the total number of customers served is 5084. Then you can see a few most important things, that is total number of entity that came is basically 7134, whereas the number of output is basically 5084. So there is huge number of gap between the people that came in and people came out. So they definitely have some issue with the banking system, because all the people that came to the system couldn't be served, and so there might have requirement of inclusion of a window or something like that, inclusion of a resource, something like that. We'll see that in the queue itself, and we'll see that in the resource page also as well. So as you can see that the draft queue is basically performing well with very less number of average queue per queue number, whereas you can see the others queue is also performing preferably good way, whereas the signature queue have average queue length of 39.5 minutes, and withdraw deposal also have a queue length of 39.5 number of people, whereas with maximum number of length of queue as 79.7, that is near about 80. Similarly, for the withdraw depositional queue length, we can see that the average number of queue is basically 39, around 39, and maximum of queue length is around 76. So there is definitely some issue with this signature queue and withdrawal queue. Similarly, you can see number of waiting in the queues also. Here in signature queue, you can see around 355 people are waiting on an average, with a maximum number of waiting as 717. Similarly, with withdraw and depositional queue, we can see 677 number of people are waiting on an average, whereas 1332 is the maximum number of people waited at some point of time. So when you see the resource, this shows much clearer view that you can see here the manager and window 1 having the highest utilization of resources. See, for example, here with the window 1 is basically completely wired out with one utilization value. That means almost all the time it has been busy. Till it couldn't produce, it couldn't serve all the people. Similarly, manager also is busy with this. This 0.991 means it's basically near about 1, and it is only this much less is because the manager's work immediately didn't start. It starts after the first process has completed his work. So seeing this, we can decide that there is definitely some issue with the window 1, and window 1 is not been capable to cope with the customer's requirement. So as you can see here also, there has around 1332 number of customers which were unserved and still in the queue over the period on which we run. Similarly, in the signature also, there are 716 people who are not processed. So to cope up with this situation, what we will do is that, so we will add resource to this withdraw or deposition window. That is, we are trying to make another window for this withdrawal and deposition counter. And for signature, we can put another signatory authority. For that, we can suggest to the bank authority that we can put. I mean, first of all, let's try to see if we include this one resource to these two processes, and then try to find out how the system is behaving, and after that we can suggest that these things can be done. So we will go to the resource block, and we'll add one more resource to this window. Say, for example, see there is a resource block. You can see there is window, then type of the capacity, fixed capacity, then there is a capacity block on which we will put 2 instead of 1. Similarly, for the manager also, we will put 2 instead of 1. Now we have 2 windows for this withdrawal or deposition work. One window for this draft, one window for the others, and 2 window for the making the signature in the draft. Now with this, we'll run the model again with the previous similar. See, when we add one resource to one process, that will mean that the mean and standard deviation of the process remains same. Only we are adding one more window for this particular process. So again, we'll run the model, and we'll check how the system is behaving with the added new window. So we are end of the run. So as we can see now, the total number of out is 7079. As you can see here, the total entity in is 7081 and out is 7079. So we have done pretty well with adding these 2 resources to the system while satisfying the customer's requirements. Now, when you see the queue, you can see that the waiting time has been reduced significantly for the withdrawal. So, has been reduced significantly for the withdrawal depositional queue and signature queue. Similarly, number of people waiting in the queue also have been reduced significantly for these two queues. Similarly, when you see the utilization of the resources, then also you can see there is a significant improvement in all these cases. So, in this way we can do this analysis of this, and we can try to find out whether we can add a resource or not, we can remove a resource or not, this kind of things we can do. So, this is the end of the first case. So, we will go to the second case, where as we have already said that we will not change variety of the customer, we have only 3 kind of customers. So, for the second case, what we are considering is that we have different arrival rate for this one. That is, we are not saying that we are not dividing the customers after they arrive. We know that the arrival rate of different customers, and this case also the windows which serves the different kind of customers are different. So, that is what we are doing in this case is that we are using different create mode for different type of customer on the same simulation model. Similar to previous case, we will also try to draw the process here first, and then we will go to the simulation model. So, as you see that we have 3 kind of customers. So, we have 3 create modes here, say C1, C2, C3. C1 is for withdrawal deposition, C2 is for demand draft, and C3 is for other services. So, similar to previous one, here also we have a different window for different processes, that is withdrawal and deposit, that is draft making, that is other. As we have said, the draft making process have another draft making system has another process that is making a signature. Then finally, we can make the exit node as individually different, or it can be made as same, and putting them in the same exit window also is applicable. So, since we have different create more nodes for different processes, different customers. So, we need to redefine, we need to add the different arrival rate for different these create nodes as well. So, let us go to the Arena again, and we will show how we can incorporate this model into the Arena. Okay, so we need to save the previous model first. Let us save it somewhere around. Why it is not saving? Okay, I haven't closed it yet. Save as. Now, we will take another open new file, and then we will try to develop the model that we have just saying about. So, as I said earlier, we will have to make 3 create nodes. Similarly, in correspondence to each create node, there is at least one process. And since for the draft making process system we require another additional process, so we will put it there. So, we will here put 3 separate disposal nodes. However, if we put one only disposal node and they connect all these 3 to the one disposal node, that also can be valid model, and that also can be run. So we are joining this, very similar to the previous one. We'll put values to these all these nodes. First of all is create node. Create node 1 is basically the customer who comes to deposit or withdrawal of money. Similarly, we will use random exponential distribution. Say for example, the value of this random exponential distribution is say every 3 minutes one customer come for deposit and withdrawal. Similar to this is basically customer draft. Say for example, in every 5 minutes one customer comes for making a draft. So third one is customer who avails other operations. So say for example, here also we'll put, say for example, every 6 minutes one customer arrives for making the draft. Similarly, we will rename the processes as this process is deposition, withdrawal of money processes. Similar to previous one, here also we will use cease delay release. We will add resource name window 1. We will use normal distribution with 5 as a 5 minutes as a mean and standard deviation of 1. Really, here also we will make the process name as a draft. We will cease delay release. We will put the process name as window, resource name as window 1, window 2, sorry. There is normal distribution here also with a mean of say 3 minutes and standard deviation of 0.5 minutes. Well, the process 3 also will rename it as other. We will cease delay release. We'll put it as window 3. With normal distribution, we keep the value as 4 minutes with standard deviation of 1 minute. Similarly, here also we'll put the process name as signature. This is delay release. The manager will do this process, so we'll put manager as the resource name. Here again we will put that as 10 minutes with 2 minutes of standard deviation. So here for example we can keep this name as exit 1, exit 2 and exit 3. So now let's run this project again. Okay, before running we need to always check this window, that is run setup. Otherwise if you don't check this, then it will go for infinite run and you can never get the result. So every time we develop a new model, you need to check this window run setup first. So similar to previous one also, we will do run for 1 month, 8 hours per day, 240 hours total run length. So we'll run it again. We'll make it fast to reach to the result. Result has arrived, so you can see total number out is 6729. As you can see here also, there has entity number 1, I mean number of entity in is 9919, number of entity out is 6729. So they definitely have some issue with the system which restricts this many number of people to get served. This can be found out by two things. Number one is queue. When you see the queue, there again you can see that deposition and withdraw counter is basically always have an average value of queue length as 48.2476 with a maximum value of 93. Similarly, the signature case, I mean the manager also have a queue length of average queue length of 59.1700 and maximum value of 117. Similarly, with the on the number of waiting, you can see this number of waiting window. You can see that there has an average number of people waiting for getting served in the window 1 is around 937.726 with a maximum value of 1845. Similarly, for the signature queue as well, you can see the average value of people waiting in there is 684.43 and maximum value of within maximum value of 1343.00. So when you see the resource utilization case, you can see very similar result has been cited as we have shown in the last case also. The window 1 and manager is having very high, higher values of the resource utilization. So similar to previous one, we can also do add resources to these two processes, and we can do the way we have done it in the similar previous case. You can add one resource in these two places, and we will run it again. We done it right. एक minute. Okay. ठीक. Now when we see the result that the number of out has been increased significantly. So similarly, as you can see, there is really very less difference between numbers or number of people who went into the service and number of people who got serviced. So though their number is very much nearer, but there has some issue with this because you can see there is around 70 people, 60 people are not served in the system. So we will see this by analyzing two things, that is number of queues and number of resources. So when you see the queue window, you can see that the signature has always been found with queues with average number of 5 and maximum value of 8. Similarly, number of people waiting in the queue also is very high for the signature. As you can see, there is around 61 people are waiting in the queue to get their draft signatured with a maximum value of 102. When you see the resource utilization, here also you can find that the manager is having very high utilization value with 0.9938. Others have predominantly good utilization values, not like that much significant. So here we can conclude that the two managers, I mean two signatory authorities, are not even capable of doing all the signatures. As you can see here also, there are around 51 customers who are not getting not been served in the signature, who are still in the queue after the completion of this run. So to add that, that can be a managerial decision whether they want to add another queue and another, I mean whether they want to add another manager or they want to go with this thing, because model may have some differences in with the real life system, because we already have we already have said that we are using random exponential distribution with one arrival for 5 minutes. There may be some there may be in real life cases that this is not exactly the same thing. So and also the number of unsatisfied, I mean undelivered customer is very low, so manager can the management can take decisions upon whether they want to add another regulatory authority or not. So that's all about these first two cases. We'll discuss about other cases in the next lecture.